So I basically have drawn out the shape that I want of my knife here, and I am using tool steel, and this has a carbon content, at least this piece, that is pretty close to 1095, but they didn't have 1095, but I think this is going to work just fine for what I'm planning on using this for. And I've kind of drawn this out. I'm not going to be having a full tang on this. I'm actually going to end up shortening this a little bit, but there's reason for that. I'll probably go over it a little bit later. But I think that anytime that you build a knife, you're building a tool, right? So you've got to be thinking about what you're planning on using it for, and it's custom to the way that you use the tool, right? There's not a knife that one size fits all. I honestly believe that, and people get into big disagreements about how a knife is supposed to be built and what steel and all sorts of stuff, and it's ridiculous. And even the tip here, some people would disagree with how I'm doing this, but like I said, there's a method to my madness, and I'm not going to use an angle grinder to cut this. I have one. But I don't see the need for it. I tested my jigsaw with a metal cutting blade, and it's working. So I'm going to be a little bit more accurate being able to do this. And I've got everything clamped down. So let me go ahead and make my first cut here. Did this already dull or something? Yeah, it did. Son of a bitch. Because I had made a couple of cuts and it was working pretty good. Let me use a diamond blade. Let's see if a diamond blade works better. So I'm using a diamond blade to cut this in my jigsaw. It's slow going, but it does a trick. And I do have an angle grinder, but I'm not going to use it. I don't really see a need for it. So I've been able to get a pretty straight cut with the diamond blade in the jigsaw. And then for those that don't know, the diamond blades in the jigsaw, like in construction all the times, we use diamond blades to cut through cast iron pipe and all sorts of stuff. So if it can cut through cast iron, it's going to be able to cut through tool steel. So that made a good cut. And now what I'm going to do is I'm going to cut off where the tang is, the end of the tang. And like I had mentioned before, this is actually going to end up probably not being this long because I have some plans for the handle. There's some stuff that I want to do to this. And I'm not going to call this a survival knife. I'm going to call it a multi-tooled knife that you can use in a survival situation. That's probably better, right? Because I want this to be, I don't want to have it where it's just one single tool. I want it to be where I can use it for a number of things. And that's why I'm kind of designing it the way that I'm designing it. And it'll make sense by the time that I'm finished and everything. So now I'm going to use the diamond blade once again, cut this off. And then I just have to deal with these two sections. It might be quicker for me to grind that off than to cut it. I'll deal with that when it's time. So now it's time to straighten these edges up, make them nice and flat and stuff, take any sharp edges away so I don't cut myself while I'm working on it. And then I'm also going to end up putting a bevel on both of these ends. I'm just going to try to take the vast majority of this off, and then I'm going to shape the rest of it with a sander. It's alright, that camera picks up pretty well. So now I'm going to use the belt sander to try to get this perfectly straight. I've got some water over here, so when it starts getting too hot for me to hold, I can dip it in there. I'm going to keep working this, and as soon as this is done, I'll go ahead and turn the camera back on. We can go ahead and start talking a little bit about the steel that I'm using, since I haven't really done that yet. This is O-1 tool steel. Okay, so if we cruise up here, and the O stands for oil hardening, and this piece is 1/8 of an inch by 1.5 inches and 3 feet long, and I got this for about $34 at my local steel supply company. And a lot of people like 1095 steel, and the 95 just basically tells you about the carbon content of the steel. The 10 is just basically telling you it's iron and steel. When you start looking at things like stainless and everything, the numbers are a little different. But if the numbers basically tell you kind of what you're dealing with, right? Like what's the alloys? What's in there? Now, I think tool steel is going to work better for what I want to do with my knife and the purpose of this knife. There are some people that are hard chargers, they're traditionalists, they want to use 1095, 1075, stuff like that. I think tool steel is good, and I'm going to go over the reason why I think that this is actually a better steel to use. Okay. So if we end up looking, let me zoom in on this. Okay, of the nominal analysis. This is basically going to end up telling you what is inside this steel. Okay, and steel is ultimately nothing more than iron. Okay, iron with a little bit of carbon in it. Boom, you got steel. But what they'll end up doing is they'll start adding other things to it in order to change its properties a little bit. So if we look at the carbon content of the tool steel, it says it is 0.90. Okay, well, 1095 is anywhere from 0.90 to 1.03. So 1095 has a little bit more carbon in it. Okay, but I wouldn't say a significant amount. Okay, in fact, depending on the piece you get, it's going to be identical because it starts at 0.90. Okay, and this one is 0.90. Okay, so carbon content, it's very similar. If you ended up getting a piece that was like 1.03, I think that's actually a little too much carbon in a knife, but to each their own. Okay, so coming over here, we have the manganese, and then the manganese, you'll see on the tool steel, we're dealing with 1, and as far as the 1095, it's about 0.30. Manganese does something very similar to what carbon does, but just not quite as good. It adds to the strength, and it adds to the durability and things, and it changes the cooling rate when you're hardening it and stuff. But you'll see that the manganese is a little bit higher on the tool steel compared to the 1095, which is 0.30. Okay, so we're going to have a little bit of extra hardening ability and stuff like that with the tool steel compared to the 1095. We have tungsten. Okay, now tungsten is some pretty hard shit, right? And it's really heat resistant, where the 1095 doesn't have anything. Okay, but the tungsten, anybody that has done blacksmithing and stuff knows you can't really hand forge or forge like something that's made out of tungsten. You can get it to like a really, really hot temperature, and if you take a hammer to it, it's just going to shatter. It's not malleable. Okay, so this is going to add hardness. And then we have chromium, and the chromium is an anti oxidizing agent, right? So if this was stainless steel, you would see chromium, you'd probably see nickel and some other stuff inside there. So this is going to help with rust prevention. And so you'll see that this one has 0.5, where the 1095 doesn't have anything at all. Right here we have vanadium, and there's a small amount inside here. And this is going to be just like the carbon and the manganese. It's going to add a little bit of strength. It's going to add, once again, durability. It's going to add hardness. It's going to add a lot of stuff. It also ends up adding a certain level of heat resistance. This is good when you're dealing with tool steels, because, like, let's say you're going to end up making something like a drill bit. All right, it's going to get hot, and you need something that can withstand some heat. So the tungsten and the vanadium, those two things would actually end up helping in something. And it's a small amount, but it has some where the 1095 doesn't have any at all. Over here I've got a couple of numbers, a couple of things. We got phosphorus, and we also have sulfur that I've written out. And the 1095, 0.05, 0.05. Now this one doesn't show the sulfur and the phosphorus, but I'm almost positive that there's some in there. But when they're making steel, they're doing everything they can to keep this number as low as they possibly can, because phosphorus and sulfur weaken steel. It damages the steel. It's not really that great of a thing to use. And they'll usually try to get rid of stuff like this by increasing the amount of oxygen that's in the around the steel during the time that they're manufacturing it, like desulfurize, I guess you can say. But these two things, because we are dealing with a standard. Let me move this. Since we are dealing with a standard that we have the Automotive Society of Engineers standard, we have like an International Steel something of America, whatever, institute or whatever standard. They basically say if you're going to be manufacturing a particular kind of steel, you know, it has to meet these requirements. It has to, right? And they do that because steel is used obviously in buildings, it's used in automobiles, it's used in boats and planes. And if you don't make these things exactly the way that, you know, they say it should be, you're dealing with a steel that could potentially give out on you, right? And that's no bueno. Now, when you get stuff that's made in the United States, or you get something that's been examined and you know that it's done properly, you're good to go, because you're going to be dealing with numbers that are really close to this. But let's say you end up buying something that was made in China, okay? And it says it's tool steel. We don't know if it's really going to match this, because we don't know anything about the manufacturer, right? And so when you end up going, because I've seen people, they make knives or whatever, and they'll take something like an old flat bar or something like that, like an old pry bar, like an old flat bar. Some made in China they got at the dollar store, you know, and they assume because of, you know, it looks like it's some type of tool steel, they're going to assume that this is actually what it's made out of. But we don't know that. You know, it could just be a mild steel that somebody has just, you know, hardened to kind of give the impression that it's tool steel when it isn't. So it's like, you know, being safe, you know, you just go and you purchase it from a reputable steel company. But even though I think that you could still make a knife out of cheap steels and it would work just fine, it's just not going to hold an edge for a long period of time, or it might bend on you real easy and stuff, you know, but it is what it is. But this is what I'm using. I'm using my my O-1 tool steel, and I think this is going to work out well. I think this is going to work out well. I have to build a forge, something that I can use to heat up my knife. I don't have anything like that around the house, but I have an idea on how to make something specifically just to do a knife that's real cheap. There's no reason to spend a lot of money on it. And that's going to be the next step. So now I've got to harden this thing, and I'm going to show you my awesome forge. People are always going out and building them and stuff like that, and I got to tell you, I actually kind of started, but then I started thinking about it, and I'm like, why do that when this is probably going to work? So charcoal chimneys are made out of stainless steel. Stainless steel melts around 1500 degrees or so, depending on the type of stainless. We only have to bring this blade up to about 900 to 1000, so I should be able to get this hot enough to harden my knife, but not so hot that it'll end up melting this. So what I'm going to end up doing is, just like I'm going to be doing a barbecue, I'm going to be using regular charcoal because things like Kingsford don't get as hot. Let me open the bottom of this to get some air in there. I have an old container of motor oil, 5 gallons. Old used shit I haven't dropped off yet, but now we're going to get a hairdryer. And inside these holes right here, I don't have to put the hairdryer like right up against it, just kind of next to it, and it will feed this fire just fine. The blade's already orange, so will you do me a favor and kind of hold this here? Well, actually no, I'll do it. But will you give me my gloves and my pair of channel locks? Yeah, it's already orange. Okay, you can pull it away. So at this point, we're going to end up having a blade that's pretty much orange up and down it. Do me a favor, hit it with a hairdryer. I want this to be an even. And I see a red in here. Okay, watch out. This is going to flame up, probably. It smells like old motor oil. It smells like gas. Well, any ass that smells like old motor oil, I don't know if I'd want to be near it. I don't have a steak here, this would be perfect. But this is probably the fastest way to get a charcoal fucking grill lit too. You know, before I was waiting 10-15 minutes. Look at that. Perfect holes, man. I wouldn't do that if I were you. Still a little warm. It's got an ever so slight bend in it, but I'm not really going to sweat that. So if this is hardened, it should just kind of skate over. But I wouldn't say that it's as hard as I would like it to be. It's red. Okay. Okay, it's red. So let me grab a glove here, which I should have some back out there. I don't know where the fuck they are. Oh, there it is. But if I pull this out now, you're going to see that the whole knife down there is bright orange. And here we go. And I'm moving this back and forth. They say that you shouldn't move it side to side because it might warp. But honestly, I think that would only happen with a sword or something. I don't think that would actually happen with a blade like this.